Let's come up with a formula for finding the surface area of a cylinder, like this one here. Let's say the radius of this cylinder's circular base is r, and the height of this cylinder is h. Now to find the surface area of this cylinder, there are three surfaces we'll have to consider. The first two are the circular base down here and the circular top up here. And then we'll also be looking at the rest of the cylinder's surface, which is called the lateral surface. The lateral surface is curved, and finding its area will be tricky. So let's take a closer look at the circular top first. As we said, the top of this cylinder is a circle with radius r. So in terms of r, what's the area of this circle? If you're not sure, click over here to review. Exactly. This circular top has an area of pi times r squared. Now before we find the areas of this cylinder's other surfaces, what's the circumference of the circular top in terms of the radius r? We'll be needing this later on in order to find the area of the lateral surface. Right, the circumference is 2 times pi times r. Now let's return to our original view of the cylinder. You found that the top circle has an area of pi r squared. Great, so we know the area of one of our cylinder's surfaces. We also know the area of the other circular face. It's also pi r squared. So that's two faces whose areas we know. All that's left is to find the area of the lateral surface, and we'll find it by unrolling the cylinder. As we do this, keep in mind that we're also unrolling this circumference up here. Okay, here goes. And there you have it. We've unrolled the cylinder's lateral surface into a flat shape. This side up here is the unrolled circumference, so its length is 2 pi r. And this length over here is the height of the cylinder. Notice that we have right angles in the four corners of this quadrilateral. So what kind of quadrilateral is our unrolled lateral surface? If you're not sure, click down here. Precisely, we've unrolled the lateral surface into a rectangle. So in terms of r and h, what's the area of the lateral surface? That is, what's the area of this rectangle? If you're not sure, click here to review. Excellent work. The area of this rectangle is its length, 2 pi r, times its width, h. So that means that the area of our cylinder's lateral surface is 2 pi r h. Now don't forget about the circular faces at the top and bottom of our cylinder. So putting everything together, the circular faces and the lateral surface, what's the total surface area of this cylinder? Nicely done. As you found earlier, both the top and bottom circles have an area of pi r squared. And so the total surface area is pi r squared plus pi r squared plus 2 pi r h. Pi r squared plus another pi r squared is 2 pi r squared. So this is the formula for the surface area of a cylinder with radius r and height h. It's 2 pi r squared plus 2 pi r h. Let's take this formula for a spin with a sample problem. Here's a cylinder, and let's say its radius is 1 and its height is 3. What's the surface area of this cylinder? Let's come up with a formula for finding the surface area of a cone, like this cone here. Let's say the radius of this cone's circular base is r, and the height of this cone is h. Now to find the surface area of this cone, there are two surfaces we'll have to consider. First, there's the circular base, and then we'll also be looking at the rest of the cone's surface, which is called the lateral surface. The lateral surface is curved, and finding its area will be tricky. So let's take a closer look at the circular base first. As we said, the base of this cone is a circle with radius r. So in terms of r, what's the area of this circle? Exactly. The base of the cone has an area of pi times r squared. Now let's return to our original view of the cone. Before we find the area of this cone's lateral surface, let's first calculate its slant height, which is the length of this straight line connecting the apex of the cone to a point on the circular base. Suppose the slant height of this cone is s. Notice that the cone's radius, height, and slant height form a right triangle where the slant height is the hypotenuse. So use the Pythagorean theorem to find an expression for s in terms of r and h. Great! You're almost ready to find the area of this cone's lateral surface. We already know that the base has an area of pi r squared, so let's get rid of it for now, leaving us with the lateral surface. Next, we'll be unrolling the lateral surface, making it a flat shape whose area we can find. But before we do that, you should also calculate the circumference of the cone's circular base in terms of the radius r. We'll be needing this for the next step. Exactly. The circumference of the circular base is 2 pi r. Also, don't forget that we've been calling the slant height of this cone s. Okay, it's time to unroll this cone so it's a flat surface. If we look straight down at it, we can see that it looks like it's part of a bigger circle. Now you already calculated the length of this arc around the edge of the surface. It's the circumference of the cone's base, which you found was 2 pi r. And these sides, over here and over here, both have length s. They represent the slant height of our cone. Let's zoom out a little bit. As you can see, our flattened lateral surface is part of a larger circle whose radius is s. Before we find the area of our lateral surface, what's the area of this larger circle in terms of s? Exactly. The total area of this circle is pi times s squared. Now our lateral surface only represents a fraction of this entire circle. In terms of r and s, what fraction of the larger circle does the lateral surface make up? Again, your answer must be in terms of r and s. This is a tricky question, so click over here if you'd like to work through it step by step. Okay, so we want to find out what fraction of this circle is taken up by our lateral surface. One way to do that is to figure out what fraction of the circle's entire circumference is taken up by the arc of the lateral surface. So first, what's the circumference of this entire circle? Right, the circumference of this circle is 2 pi times its radius, which is s, so that's 2 pi s. Meanwhile, the length of the lateral surface's arc is 2 pi r. So what fraction of this circle is taken up by the lateral surface? In other words, what fraction of this circle's circumference is taken up by this arc down here? Nicely done. The fraction of this circle taken up by the lateral surface is the arc length of the lateral surface, 2 pi r, divided by the circumference of the circle, 2 pi s. We have 2 pi in the numerator and the denominator, so they cancel out, and this fraction simplifies to r over s. So if the total area of this circle is pi s squared, and the lateral surface only takes up r over s of the circle, what's the area of the lateral surface? If you're not sure, just click down here, and we'll work through this problem together. Exactly. The area of the lateral surface equals the fraction of the circle taken up by the lateral surface, r over s, times the area of the entire circle, which is pi s squared. This s in the denominator cancels out one of the s's in the s squared term, and that leaves us with pi times r times s. And this is the lateral surface area of our cone. It's pi times the radius of the circular base times the slant height. Now the total surface area of the cone includes both the lateral area as well as the area of the circular base, which you said earlier is pi r squared. So then what's the total surface area of the cone in terms of r and s? Exactly. So the total surface area of a cone is the sum of these two areas. So that's pi r squared plus pi rs. We can write this formula a little more neatly if we first write r squared as r times r. So notice that we have a pi r in the first term and also a pi r in the second term. So if we factor out a pi r, then our formula for the total surface area becomes pi r times r plus s. So we can write this formula two ways. It's the area of the circular base plus the lateral surface area, which equals pi times r plus s. Let's try some examples. Now this cone has a radius of 3, and suppose you don't know the height, but the slant height is 7. Try using this formula to find the total surface area of this cone. Excellent work. Let's try another example. Here's a cone whose radius is 4 and whose vertical height is 3. What's the total surface area of this cone? Nicely done. You used the Pythagorean theorem and found that this cone has a slant height of 5, and then you found the surface area. Let's finish this lesson with a real-world example. Here's a teepee, and suppose its radius is 6 feet and its vertical height is 8 feet. About how many square feet of material are needed to make this teepee? Keep in mind that a teepee is just the lateral surface of a cone. The circular bottom of a teepee is usually just the ground.